Welcome to Patki Classes online sessions.
Hello students, let us get introduced to trigonometry. Trigonometry is a branch of mathematics which helps us to measure distances using sides and angles of a right triangle in situations wherein normal methods of measurements are difficult to use. The word trigonometry is derived from the Greek words tri, meaning three, gona, meaning sides, and metron, meaning measure. In fact, trigonometry is the study of the relationships between the sides and angles of a triangle. Earliest known work on trigonometry was recorded in Egypt and Babylon. Early astronomers used trigonometry to find out distances of the stars and the planets from the Earth. Even today, most of the technologically advanced methods used in engineering and physical sciences are based on trigonometrical concepts. In order to make use of trigonometry properly, one should be able to imagine or visualize a right triangle in a given situation. For example, watching the top of a structure, say Qutub Minar, while one is standing on the ground, a right triangle can be imagined. Also, standing on a balcony of a building on one bank of a river and watching a flower on the other bank, a right triangle can be imagined. To make the visualizations easier, certain considerations are needed, like considering extended objects as straight lines, neglecting at times minor differences in elevations or height, considering line of vision as a straight line, and so on. Once we are done with the visualization of a right triangle, measurements are made using trigonometric ratios of the angles and trigonometric identities. So, what are trigonometric ratios and trigonometric identities after all? Ratios of lengths of the sides of a triangle with respect to its acute angles are called as trigonometric ratios of those angles. Identities which make use of trigonometric ratios are called as trigonometric identities. There are all put together 6 trigonometric ratios. To construct trigonometric ratios, clear understanding of the sides is necessary. Of the three sides of a right triangle, the hypotenuse is the largest side. Of the remaining two sides, side opposite to angle A means the side in front of angle A. Side adjacent to angle A means one arm of angle A. Note that position of sides change if we consider angle C in place of angle A. Now side opposite to angle C is AB, which is also the side adjacent to angle A. Sine of angle A, also called as sine A, is side opposite to angle A upon hypotenuse, which is the ratio of BC upon AC. Cosine of angle A also called as cos A, is side adjacent to angle A upon hypotenuse, which is the ratio of AB upon AC. Tangent of angle A, also called as tan A, is the ratio of side opposite to angle A and side adjacent to angle A, which is ratio of BC upon AB. Cotangent of angle A, also called as cot A, is the ratio of side adjacent to angle A and side opposite to angle A. Also, ratio of AB upon BC. Cosecant of angle A, also called as cosec A, is the ratio of the hypotenuse and the side opposite to angle A. Also, it is AC upon BC. Secant of angle A, also called as sec A, is the ratio of hypotenuse and the side adjacent to angle A, which is also equal to AC upon AB. Tan A can also be worked out as the ratio of sin A is to cos A. Sin A, which is BC upon AC, and cos A, which is AB upon AC, ultimately gives BC upon AB, which is nothing but tan A. On observing closely, we infer that cot A is the reciprocal of tan A, sec A is the reciprocal of cos A, and cosec A is the reciprocal of sin A. Sin A is the symbol or abbreviation used for sine of the angle A. Hence, it is not the product of sine and A. Sine separated from A has no meaning. Similar rule applies to other trigonometric ratios also. Let's understand how does trigonometry help us to do measurements in difficult situations. For this, consider a right angle triangle CAB, right angled at B. From a point P, which is somewhere on the hypotenuse AC, drop a perpendicular on the side AB. So now we have two right triangles, triangle PAM and triangle CAB. A question arises, are triangle PAM and triangle CAB similar? On observation, we understand angle M is congruent to angle B as both are 90 degree. Angle A is congruent to angle A being the common angle. So, triangle PAM is similar to triangle CAB according to the angle rule of similarity. As triangle PAM is similar to triangle CAB, it implies AM upon AB is equal to AP upon AC is equal to MP upon PC. That is, the ratios of the corresponding sides are equal. If we consider the two ratios marked in the red and apply alternando, we get BC upon AC is equal to MP upon AP, which is nothing but sin A. Similarly, if we consider the two ratios marked in green, that is AM upon AB is equal to AP upon AC, and apply alternando, we get AM upon AP
is equal to AB upon AC, which is nothing but cosine of angle A. Also, if we consider the two ratios as highlighted in the figure and apply alternando, we get BC upon AB is equal to MP upon AM, which is nothing but tan of A. This shows that trigonometric ratios of angle A in triangle PAM and triangle CAB are equal. In other words, the values of trigonometric ratios of a particular angle do not vary, that is change, with the lengths of the sides of the triangle, provided the angle remains same. Ultimately, it means trigonometric ratios found or calculated in one right triangle can be applied as it is in other right triangle if the acute angles are equal. So, how does it help us to do complicated measurements? It's pretty simple, yet highly logical and smart application of trigonometric ratios. What one needs to do is work out the trigonometric ratios of an angle using a right triangle of known dimensions and apply them in another triangle having equal angle but unknown lengths of the sides.
The first use of sine, the way we use today, was in the work Aryabhatiam by Aryabhat in the year AD 500. Aryabhat used the word Ardhajaya for half chord, which was shortened to Jaya or Jiva in the due course of time. Aryabhatyam was translated into Arabic. However, Jiva was retained as it is. But when Arabic version was translated into Latin, Jiva was translated as sinus, which means curve in Latin. Soon, sinus, also used as sine, became common in mathematical texts throughout Europe. An English professor of astronomy, Edmund Gunter, first used the abbreviated notation sine. Cosine and tangent originated much later. Aryabhat used the word Koti Jaya as complementary to Jaya. The cosine function arose from the need to compute the sine of the complementary angle. The name cosinus originated with Sir Edmund Gunter. However, an English mathematician, Sir Jonas Moore, in the year 1674, first used the abbreviated notation cos. If we know any one of the trigonometric ratios, can we obtain the others? Yes, we can. Let's see how. If in a right triangle ABC, sine A is equal to 1 upon 3, then this means that BC upon AC is equal to 1 upon 3. That is the lengths of the sides BC and AC of the triangle ABC are in the ratio 1 is to 3. So if we assume BC is equal to K, then AC is equal to 3 times K, where K is any positive number. To determine other trigonometric ratios of angle A, we need to find the length of the third side AB using Pythagoras theorem. Therefore, AB square is equal to AC square minus BC square, which is equal to 3K the whole square minus K square, which is equal to 8K square, which is equal to 2 root 2 k the whole square. Therefore, AB is equal to plus or minus 2 root 2 k. So we get AB is equal to 2 root 2 k, as the distances can't be negative. Now cos A is equal to AB upon AC, which is equal to 2 root 2 k upon 3k, which is equal to 2 root 2 upon 3. Similarly, you can obtain the other trigonometric ratios of angle A. Since the hypotenuse is the longest side in a right triangle, the value of sin A or cos A is always less than 1, or in particular equal to 1.